Today we want to talk about logarithms, and we want to be able to evaluate logarithms and rewrite them in terms of exponents. And so the first thing we're going to write down is log base a of x. What that actually means is like, what does a logarithm mean? That's just another way of writing a to some power is equal to x. So again, the question that we encountered the other day that I put forth to you guys at the end of the class was this. I said 4 to what power is equal to 20? For the 5th power, that's like 1024. Something like that. But the question is, what about 4 squared is what? And 4 to the 3rd is... So you know it's going to be somewhere between 2 and 3, right? Closer to 2. But knowing exactly what it is, that's kind of tough to think of, isn't it? Well, the answer is this. It's a logarithm. My base is 4. The number is 20, and that will give me my exponent. So whatever that is the answer. And we can figure that out on our calculator eventually. How does your calculator do it? It uses calculus, and you'll learn that some other time. So let's try to rewrite some of these problems so we understand them. Express the following in exponential form. This number right here is my base. It always solves for the exponent. Logarithms give you the exponent. That's why they're so valuable. So the base is 2. What's the exponent? Starts with F, rhymes with Ive. 5 equals 32. That's it. What's the base for B? Exponent? Did Miss Nelson do a loop-de-doo thing for you? Circle the base and loop it around? She did it better. Oh my gosh. Oh, Senior, you're in big trouble. Alright. Log base 6 of 36 is equal to 2. So here's what she did. Circle the base. So 6 squared is 3. What? Okay, come show me. Go, Chris and D. But see, when you do that, what I think is 6 to the 30 raised second of 6 power, like. Yeah. So she's not actually teaching you right. She just say 6 squared is 36. Okay, all right, whatever. I'm just trying to understand what she's thinking. Just difficult to do. All right, so the next one, base. Is that true? It's 1201. Next one I messed up. Should be a 5 on the end here. Base, exponent, next ones are different, aren't they? So next one's, write this down at the top. Log base e of x is the same as log base 2.71828 yada yada of x, which is the same as natural log of x. Okay? E is a very special number. If you look on the very back of your notes, if you flip to the last page, I've got some notes that you're going to be able to use on your tests. They're all printed out for you. For the remainder of the year, I have stuff that I'll be giving to you, okay? Helpful stuff. Stuff that you'll want to take with you to college. So nobody will organize the stuff for you. Okay, so for the rest of the year, even through all trigonometry, I got some great stuff that people still use in calc and even in college. So you can see at the top there where my fingers are, E is 2.7182818. If you were to try to describe the number E to somebody who knew nothing about it, you might say it's similar to the number pi. Pi has to do with what? On Thanksgiving, circles, right? Yeah, pi has to do with circles. And E has to do with the natural growth of things. So for example, how quickly is the bacteria underneath my toenails growing? I would use probably the number E for that because it's a continuous growth rate, okay? And so things that grow in nature, okay? Population of rabbits. We would use the number E as a base. So E is a very special base that helps represent growth of stuff, all right? And I can show you how they actually come up with this number 2.718. I'll show you later on how they do it, but it's pretty cool. Question. Ln means natural log, yes. And so you kind of almost want to see NL, right? But it's Ln. And so it's normal to kind of feel that way, but when you see Ln, it is definitely natural log. And if you look at your calculator, it's right over here. So they got log in capital letters, they got Ln in capital letters. It's only expressed that way on some calculators. All the time you will see me write Ln as it is in your book. Small l, small n. Okay? So that's what those mean. So anytime you see natural log, you always write base E. What's the exponent? 1. Is e to the 1 equal to e? Anything raised to the first power is itself. So yes. Here you got base e raised to the 0 power is equal to 1. Is e to the 0 power equal to 1? Sure is. Okay? You may say that you don't like natural log. You don't have to like it. It's not part of the requirement. It's kind of like the Beatles. Does anybody here like the Beatles? I can't stand the Beatles. But I'd much rather listen to the Rolling Stones or Led Zeppelin. But the fact is, I understand why people like the Beatles. I understand why they're influential. Same way with natural logarithm. You don't have to like it, but you got to understand why it's important. Because if there's something that you continue to see in calculus, natural logarithms is one. So, exponential, or express the following equations in logarithmic form. So now we're going to take this, we're going to write it as a logarithm. So log, what is my base? 2 of 16 is equal to the exponent, 4. So base goes in the base spot, exponent is what it's equal to. And the other number just goes there. Log base 10 of 100,000 is equal to. Now here's another thing, you guys. When you see natural log, do you write the e for the base? No, it's just assumed. When you see log base 10, they don't write 10. Everything is assumed to be base 10 unless you see it differently. So I'm going to write another statement below. Those are the same. Log base 10 of 100,000 is 5, and log of 100,000 is 5. Like on your calculator, again, you see log and natural log. Log has a base 10. That's just the way it is, unless it's specified differently. So like here, is the base 10? No, so we write 8. Log base 8 of 1/64, negative 2. Next one, log base of, always gives you the exponent. Always gives you the exponent. Next one, log base 10. So do I have to write the 10? No. Of what number? What's the exponent? Log base E. Instead of writing log base E, I can write natural log of e is equal to 1. We okay? Ready to step it up? Let's step it up. You guys are enthusiastic on this Friday. Log base 4 of 64, okay, equals something. What is that something? 4 is my base to some power is equal to 64. What number do you raise? What do you raise 4 to get 64? 3. So the answer is 3. Next one is 3 to what power is 1/9? Very good. Positive 2 would give you 9, so negative 2 gives you the reciprocal, 1/9. The next 4 are super important because there's something wonderful that happens here. Log base 8 of 8. 8 to what power is equal to 8? 1. See what happened there? Look at this. Log base of 8, and then I had a base 8 to 1. Everything went away, and I just was left with 1. Like, don't even look at that. Log base 8, 8 to the 1, I was just left with the exponent. Watch what happens here. Yeah, you got, you'll see we'll make the connection here. Base of 5 to some power is equal to 5 to the x plus y. Well, what fills the spot for the question mark? X plus y. Look again, folks. Log base 5 of 5 to the x plus y. It's almost like the log base 5 and the 5 went away. You're just left with the exponent. Sit down your pencils. Don't write this down. Watch this. Okay? This is where it's all supposed to come together. What is the additive inverse of negative 2? 2. What is the multiplicative inverse of 1/3? What is the function inverse of f? You remember when we did those, what we got? We got x. And here's what you're seeing right now. If you have a log with a base of a base to the x, those cancel and leave you with just the x. Logarithms and exponential functions are inverses of each other. So go to the top of your page, and right up here you see log base a of a to the x. Here you have an exponential function, and you have a logarithm. Those are inverses of each other. They undo each other. And so they cancel off, and they're just left with x. And again, you have an exponential function, a to a power. It happens to be log base a. Those are inverses of each other, and you will be left with just x. Yep. If you see the same base in the logarithm as the exponential function, those cancel each other out. And that's going to be super important when we get to lesson 4 for evaluating this stuff. So look at letter E. What can I do for letter E right now? Cross off the 3 in the log base 3 and you're left with 7. And for F, that's like log base what? E. And then 1 over E squared is like E to what power? 1 over E squared is E to the what power? Negative 2. So this is the same thing as that. So what can I do? Cross off the log base E and E, because those are inverses of one another, and I get negative 2. So inverses of exponential functions and logarithms, you know, they're one and the same. Super important. Good job. We go to the back side. Now we're going to write the logarithms as exponential expressions in order to find a missing variable. In this case, we're going to find x. So log base 2 of x equals 3. I'm going to rewrite it. What's my base? What's my exponent? So 2 to the third is equal to x. So x is equal to 8. Letter B, what's my base? Base is x. Exponent is equals, what is x? 10. What number do you square to get 100? Square 10. C, the base is 5. The exponent is x. What power do you raise 5 to get 125? 3. When you just look at D, what do you think the answer might be right away? Yeah, I think 7 right away, but it's not absolutely correct, because if you write it out, you get x to the 1/2 power is equal to 49. So it's not asking the square root of 49, it's saying what number do you take the square root of to get 49. You would have to square both sides, wouldn't you? So when I first wrote the problem, and I actually wrote the problem wanting to come up with 7. That's how I wrote the problem. But it just reminds you got to be careful. You can't just think, okay, 1/2 means square root, 49, square root of 49 is 7. That's true, but that's not how this is set up. X in this case happens to be 2,401. Because that's the number you take the square root to get 49. Ooh, this one's tricky. We'll call that x to the x power is equal to 0. What number do you, or what power do you raise 2 to in order to get 0? Anything in 0 power is equal to 1. 0 is a very good guess. What'd you say? You said something. I thought you said something super smart. Okay. All right. Well, we'll show you something, and then you can try to take credit for it if it works out, okay? All right? So, which one of these graphs, the blue one or the green one, are you familiar with? The blue one, right? And you see that it has a horizontal asymptote of 0, and it passes through the number 0, 1. I just told you that exponential functions and logarithms are inverses of each other. Remember when we talked about inverses? They are reflected over this line, y equals x. Well, if I take the blue graph and reflect it over the line y equals x, I get the green graph. And the green graph is a logarithm. So you can see instead of passing through the point 0, 1, it passes through the point 1, 0. But look at the green graph. We said the domain for the blue graph. What kind of numbers can you plug in for the blue graph? You can plug in anything you want. But you can't get out what kind of numbers? Negative. Well, it switches for the green. What kind of numbers can you get out? Positive or negative. But what kind of numbers can you only plug into the green function? Only positive. In fact, you can't even plug in 0. Okay? So these are inverses of each other. They have a relationship. The domain of the blue is the range of the green. And the domain of the green is the range of the blue. They switch. So you can see this one has a horizontal asymptote of 0. This one has a vertical asymptote of 0. All that stuff switches. They just trade. But you can see from the green graph, you can't plug in anything off in this direction. Nothing over there is available, including the number 0. So if you look at this problem right here, log base 2 of 0, if you tried on your calculator to take the log of anything of 0, you get a domain error because you can't plug it in. It says, I can't plug it in. It's not part of the domain. That's a problem for me. And again, you get a domain error. So you see the problem, don't you? That's a big problem. So, log base 2 of 0. No solution. Or you could write undefined would be fine as well. So Taylor, is that what you said? Yeah, exactly. There you go. A for the day, Taylor Martinez. All right, log base 10 of x is equal to -3. Base is 10, exponent is -3 equals x. What's x going to be? Yep, 1 over 1,000. Awesome. That's your basic introduction to logarithms. Rewriting is exponentials and working back and forth. Okay? We want to do these last 4 problems. They go through pretty quick. We're now going to do the same thing we did yesterday, which is write functions, except instead of being y equals a to the x, we're going to write y equals log base a of x. Okay? Now, what point do you notice these all pass through? 1, 0. Is that the same as yesterday or different from yesterday? Different. From the graph I showed you guys, you can see the ones we graphed yesterday went through 0, 1. The ones we graphed today, they all go through 1, 0. Okay? Because anything to the 0 power is equal to 1. And that's why we have the logarithmic function looking that way. So, we go back here and let's try to write it out. Okay? What is my, I'm not going to use this one right here. This just tells me it's going to be a logarithmic function. I'm going to use this one. What's my y value? 2 equals log base a. We got to find out what a is, just like yesterday. X value is 25. Okay. I don't understand what that means. That's confusing to me. I look at that and I'm like, got no idea. So I need to put it in a different form that I can understand. The form I can understand says base a to the second power is equal to 25. What number do you square to get 25? So therefore my function is y equals log base 5 of x. Next one, my y value is -1 equals log base a of 1/6. Again, I look at it, I don't really know what it means. So I rewrite it in exponential form. Base a to the -1 power is equal to 1/6. What number do you take to the -1 to get 1/6? 6. So we have y equals log base 6 of x. And that's my function. C, I have a y value of 4. I don't know what it means, so I rewrite it in a form I can understand. A to the 4th power is equal to 10,000. What number do you take the 4th power to get 10,000? 10. So you have y equals log base 10 of x. Your book would not write that. It would simply write y equals log of x. Because it doesn't write a base of 10 because it's always assumed to have a base of 10. So that's how they would write it. I don't care if you write the 10. It doesn't matter to me. It's just you got to understand what your book has and how people generally write it. You have to understand that logarithms always have a base of 10 unless it's stated otherwise. Okay, and the last one. 1 equals log base a of 7. So that reads a to what power? I'm sorry. A to the 1st power is equal to 7. 7. So y equals log base 7 of x. That's my function. Good. If it's easy for you, you're on a good path right now. Okay? Here's your assignment. Looks like a lot. It's really not that bad. These problems, we just did what? 36 problems in class. So these could go pretty quick. Shout out to Crystal and to Bryn. We hope you guys are doing well. Come back safe.